As a group, we focus on colloidal nanomaterials. These are tiny objects made of inorganic cores. For example, semiconductor materials, could be plasmonic, it could be perovskite materials, and they have an organic shell that plays two roles: electronic passivation of that core, but also promotes the dispersion or the affinity of the nanocrystals to surrounding media. So a properly made nanocrystal could be displaced from one environment to another by modifying the nature of the ligand on the surface. We grow this system using hot temperature reaction, solution phase bottom-up growth, and we characterize them using techniques, for example, as TEM, X-ray diffraction, and scattering techniques. And we also spend a lot of time optimizing the interface. So our work has a large component of it that looks at the interfacing of these nanocrystals with the surrounding worlds. Now, we design a variety of ligands that are optimized to interact optimally with the surface of the nanocrystal in question, but also to promote the interfacing with the surrounding environment. That could be, for example, attaching them to a small molecule, a dye, a metal complex, or a larger object, let's say a protein or a peptide. What we do with these complexes, we look at physical processes that involve, for example, energy transfer, charge transfer interactions that could involve catalysis, for example. In terms of application, we use those complexes or hybrid assemblies and combine them with the photophysics we're looking at, with the energy transfer, charge transfer interaction, or catalysis, for example, to design sensing assemblies that play a specific role. For example, we look at detecting the presence of certain antigen, certain ions. The work basically allows us to cover a wide area, ranging from physics to chemistry to engineering to biology as well. The goal is to really be able to integrate these nanocrystals in any environment we want. And the students will learn usually a bit of organic chemistry, and that involves the making of the organic molecules and optimizing the structure and properties. We use characterization techniques such as fluorescence, UV absorption, scattering techniques, TEM, and more recently we've been quite a bit of NMR measurement. And those could be just simple 1D NMR, multi-dimensional NMR. And we have even gone to the mag lab to do some MRI imaging.